Hi everyone, just Prasad Bansule here from IC3D, wanting to give you a bit of an update on another new feature added to IC3D STEEL, which is the inclusion of the Heavy Engineering and Research Association, or the HERA joints, which are quite widely used in New Zealand for the structural construction industry. So these structural connections are now available in IC3D Steel. So just wanting to show you a few examples of where they're available and then how they can be utilized. So if we go over here to insert joint, so under the library and getting more joints there, you'll see now, in addition to the Australian standard, we've got the HERA joints available as well for download. I've got them downloaded here, and you can see that they appear here under the library. And there's quite a few of them. There are angle cleats, base plates, some moment end plates and stiffeners, flexible end plates, lots of splices there, and some web plates as well. So I just want to show a few examples of the different ones that are available. We'll just start off with with the simple base plate. You'll notice that there are different base plates for different structural member profiles as well. This is something that's defined in the HERA standard, so we've supported that as well. So I'll just choose a base plate here for this column. We'll just select it, click next. So it's asking for a reference point and just the column body itself. Click next. So we've got an option here to select the percentage of axial load capacity. So each column can support some particular axial load, and we can, as the designer, choose a percentage of that, and the base plate will be sized appropriately. So a higher percentage means that it can support a higher load, and the base plate should therefore be a little bit wider and thicker, and so on. So if we just click OK there, and you can see that the base plate is resized. It's got its thickness there and it's positioned into place. As well as that, we've got the holes inserted there as well. And all of this sort of information is just coming from tables that are there in the background. And you can view the tables, you can edit them, you can basically change the values to whatever you like. So if you don't think that this is sort of wide enough, or you want the holes to be spaced out a lot more, then you've got that option to go in, change those values, and the joints will be updated there as well. Let's just take a look at another example, just a prefabricated channel there, so inserting a slightly different base plate design for that. So we'll just find that in the library. There it is there, one for a channel. Okay, again, just select where we would like it to go. So a couple of selections here. Again, it's asking us for the back face of the channel, and again we've just got these sort of handy tips for you there as to what you need to select. So just select the back face of the channel, select the reference point. Okay, so it's positioned itself there. Same thing again, choosing the axial load capacity, say 30%. Click OK and just do a quick rebuild to get it into place, and you can see how it sized itself and the holes are spaced there appropriately. Alright, a couple more examples there. Maybe we'll look at some angle cleats. So we'll just insert some here. So just go to just a simple single with no cope. Again, we've got coping options there as well. Okay, let's take a look at another example. We'll just insert some angle cleats as well. So we'll just go over here, insert joint, find them in the library, angle cleat, and we'll just go with a simple no cope, for example. So you can see here that we've got different, first of all, we've got double and single angle cleats, but we've also accounted for the different cope cases that are defined in the HERA standard as well. So I'll just go for a single no cope. Just go next, and we'll just go ahead and click where we want it to go. Choose the options, so a few more selections here, 3 in all, so it's asking us for a column face, then the beam body, and then just the top face of the beam to define a vertical position. So define that. And this time we've got to select what percentage of shear load capacity. So what shear load and what percentage of that shear load can the supporting beam handle there. So we'll just go with, say, the default 30%. Click OK. and you can see how it's moved itself into place, and we've got the corresponding number of holes cut on both the beam and the column there. And not only that, you'll see that the beam itself is cut back from the column as it should be, again all defined by the standard. And if we just again go to our Fastness Explorer over here, so the angle cleat, it has not only the bolts, so it's got the bolts there, but it's also got some nuts, and it's got some washers there as well. And if we export our bolt list, we can very quickly take a look at what we've got there. So we've got some bolts, we've got some washers and some nuts that are being inserted there as well, and we could export that accurate bolt list out as well. A few more examples. Let's take a look at a flexible end plate. So again, we'll just go down to end plate there, and we'll just choose one with no cope. Select where we would like it to go. Choose the appropriate face, so that's where we need it to go. The beam body, and just the top face of the beam there as well. Okay, click next. Same sort of thing in terms of the shear load capacity. Let's just try 40. And you can see that it's placed itself into position. You can see that the beam is cut back there. If I just hide the column for a moment, so you can see it's cut back there, and the holes have been cut through the column there as well. Alright, let's take a look at a slightly more complex one. I'll just go to this assembly here. So when we've got two beams together, we might want to splice them apart. So we've got a few splices available in the HERA library as well. So a few different combinations. We've got beam splices, we've got column splices, we've got what's known as a bolted welded beam splice, and moment end plate splice that can come with sort of either extended or just flush to the beams, or even with gussets as well. So let's maybe try that one there. Okay, so we'll just select where we would like it to go, and we've got a few selections to make there. So it's asking us for a beam body to align, and just select the beam body on the other side, and just a splice point to position itself along the two beams. Go ahead and select those. This time we have a combination of what are known as moment and shear loads. So you might have again just your percentage there, and there's a little tooltip telling you what you need to select. So we'll just select one of those options, click OK. And you'll see how it puts itself into place. So the plates are automatically widened, the holes are cut through, and the gussets are appropriately sized as well. And we can go again to the fasteners, and you can see we've got a total of 8 holes there. So we've got 8 bolts, 8 washers, and 8 nuts. And again, this can be completely customized to whatever fastener arrangements you might want. Last couple of examples to take a look at. Just want to take a look at one, again a similar sort of moment end plate, but one that can actually add stiffeners as well. So you can see in this case we've got a column, and we've got a beam sort of going through there as well. So if we just go into our HERA library, and we'll just go into beam to column, and we'll just use the moment end plate. Click next, choose where we would like it to go. Okay, so this has got a few sort of selections there, so we'll just select our beam, select the column body, select the beam on the opposite side, and finally just select our splice point. Alright, so it's into place there. Okay, so now this is a couple of options. So it's just asking us, well, do you want the stiffener plate to be filleted or not? The stiffener plates that appear in here. In this case, we should say yes, because you can see that the column has internal fillets as well, and just the combination of moment and shear loads as well. So we'll just go ahead and click OK. Now this is a fairly complex joint, so it'll just take a few seconds to sort of resize and insert itself. Okay, and there we are. So you can see how it's inserted itself. We've got the hole sort of coming through there, and we've got the stiffener plates, and you can see that the fillets on the stiffener plates exactly match the corresponding internal radius on the column there as well. And if we take a look, we would be able to see uh, the the bolts and the nuts and so on and so forth that have been added into along with this joint. So you can see quite a complex one there, but it's all inserted automatically for you with the few clicks. That would have taken me at least a few minutes to insert manually. Now, just in terms of the joints themselves and how they're configured, so as I said, they're based on tables. So just to show you a fairly sort of simple example of that, I'll just open up one of the joints from the library itself. We'll just go with our favorite base plate. So just a simple model, and it's just been set up with the sketch for the base plate itself as well as the holes. And if we just go into IC3D Steel joint and define joint, this is the joint definition wizard that we use. And we've got a configurator. So not to go into sort of too much detail here, but as I said, all of this is just based on tables. So you can just see a table here for the different types of profiles that we use, and for each one we've got information on what the width is, the length is, the thickness, the number of bolts, the diameter, so on and so forth. So you can see for one of the columns that I used before, I think there was a 310 118. The width of the base plate would be 350, the length would be 360, the thickness would be 10 millimeters. The number of bolts is 4, and what the bolt diameter, the pitch, and the gauge is. And these are just the values that were taken directly from the HERA standard, but if you want to change those, you can go into the tables. They come along with the library, so you can open them up in Excel, just find the corresponding entries and modify those as well. So that's just what I wanted to show you there. The HERA joints are now available for download from the IC3D Steel library. If you've got any questions, please do let us know. Thank you very much.